Good afternoon, everyone. My name is Obeho Fiku, and today I'm going to be giving you a presentation on the characterization of the Ohameva Perch Aquifer in the Kuvalai-Etosha Basin in northern Namibia using geophysical and geophysical methods. My study, I'm doing this research under the supervision of Dr. Innocent Muchingami and Dr. Josephina Hamutoko. So I'll just give my outline and I'll go to my introduction. So my study area, Ohameva Pen, is located in northern Namibia, near Okongo area, near the border of Angola. So as we all know, and as previous studies have indicated, by Hamutoko et al. 2016, is that the Ohameva area consists of perch aquifers. And these perch aquifers are, let me rephrase that. The Ohameva is located in Ohangwena, of which the Ohangwena consists of the Ohangwena 1 aquifer and the Ohangwena 2 aquifer, meaning that the Ohangwena is a multi-layered aquifer system. So we are only going to focus on the Ohangwena 1 aquifer, and this aquifer consists of perch aquifers. Evidence that shows that there are perch aquifers in this area is the hand-dug wells that the locals have dug by themselves. And the question or the research gap or the question that comes is it a recharge area or a discharge zone? So no previous resolution of hydrogeophysical investigations at Ohameva, despite their potential value in characterizing such systems. So therefore, my study is going to apply passive and active geophysical methods to investigate the lateral and vertical extent of the Ohameva Pen. With that, we'll be able to locate fresh water for the communities and to also fulfill the clean water and sanitation, which is the SDG 6. My study area, as I've mentioned previously, is located in the Ohangwena region, and it's a semi-arid area with thick Kalahari sands. The dominant rocks are mostly calcretes, and these calcretes could be the reason why the water or there are perch aquifers in the Ohangwena 1. So the rocks are calcretes, mudstones, dollarstones, and even evaporites. The elevation ranges are from 110 to 150 meters above sea level. And according to Kuhls et al., they have indicated that the annual recharge is up to 20.8, and this they have indicated this by using the chloride concentrations in the groundwater. Also, there is existence of preferred flow paths, which means that after the annual rain, the direction of the flow is to the pens because the Etosha Basin is a depression, so it will flow to the pens and to the Oshanas. And there's favorable recharge conditions that occur at the castified exposures. So my methods and materials. So the research design, formulation of the objectives, which is to determine the lateral and the vertical extent of the perch aquifers, and also the reconnaissance, which is the desktop study, and literature also helped in understanding what previous studies have done in this area. So by sampling and collection procedures, the site selection and planning was done before these measurements were recorded, and the equipment preparation also took place. For the field investigations, we had the TEM, the ERT, as well as the magnetometer and the telluric. And we were able to integrate the geophysical results by using the OSS Montage, QGIS model, and the models gave us the raw data, which we put in MS Excel, and were able to plot the boreholes on the map of Ohameva. Also, the ERT profile indicate the zones where there is a possibility of the perch aquifers. So these are just my equipments. The equipments that I used in the field. Then I'll continue to my results. So this aeromagnetic data shows two different filters that were produced in the OSS montage. The first filter is the analytical signal, and the second one is the first derivative, the first vertical derivative filter. By overlaying these two filters, we're able to determine or to create a geological map showing the anomalies from high to low, as well as the structures that could be trapping the water or potential trapping areas of the water in the purged. Sorry. Potential trapping sources of water. Okay, so this one shows a GEM profile. So station 10 is indicated over there with a red block. Shows conduct resistivity from high to low, where higher resistivity is at the top layer which is blue. This could be calcrete, for example, and the layer that's in between, the moderate one that looks yellow to red, could be the saturation zone. Also indicated on the profile there on station 10 there. The saturation zone is the one that goes from 20 to 60, and from 60 downwards, it's a confining layer, which could also be calcrete. So calcrete could also be contributing in trapping these, the water, or acting as confining layers for these purged aquifers. Ground to lyrics also shows the same, where the resistivity increases from the bottom to the top, and these moderate layers, the moderate resistivity may show fractured calcrete, and the low resistivity can show possible aquifer locations. Here I've just indicated aquifer locations also where boreholes can be drilled. The ones that are in blue mostly show where ERT was measured near the wells, the hand dug wells in the area. So for conclusion and recommendation, the aquifer depth was mapped successfully, and the magnetics mapped out the structures that are controlling the groundwater, which can be fractures or these calcretes that are trapping the water. Geophysical tools can be also effective in characterizing the purged aquifers. For example, locating the where fresh water can be found, or locating the fresh water depending on the conductivity. The geophysical methods can therefore be effective in locating freshwater aquifers, and low resistivity areas can show potential availability of saline water. My recommendation is to upgrade the vulnerable villages with protected boreholes, because to me it's not really safe that they take water out like that, and it's not sustainable use. It won't be sustainable, and it's not sanitary. My references, and I would like to thank everyone that's part of this project, and I'd like to acknowledge them too. Thank you.
Thank you very much. That's another young water professional. Thank you. Okay, we have got now time for questions. We've got any hands? I would like to see hands from this side this time, please. Unless if we've got the media this side, then. Okay. Any hands, any questions? Any comment? Oh, okay. I see one hand here. Okay. You can, and the one at the back. So we've got two hands, so you will take both at the same time. So you will go first, and then Dr. Pitts.
I see you did a lot of work to determine how deep you can find the water in the ground. Or is there any, I'm right here.
Oh.
Sorry, yeah, the light is blinding, I'm sorry. Was there any step taken further to know, okay, this is how much water there is in the ground, but anything to do with transmissivity of the aquifers or storativity? Like, you know the water is there, but if you start pumping, will it still be there?
I haven't really looked into it, but I can still, because I'm still busy with my results as I'm preparing for my thesis, so I can look into that also. Okay.
Oh,
Yes.
Thank you, Kevin. My question is on your recommendation. You indicated that the community needs proper boreholes.
Yes.
Is this based on the fact that the quality is not good? What about modernizing this hand dug well? What triggered that recommendation? Thank you.
To be really honest, when I went to the area, the hand dug wells, sometimes it's not only humans that get water from there, they also give it to the animals. So it's not sanitary because you cannot be sharing a borehole with an animal. So that's why I recommended that the government should really work hard in drilling boreholes for these people, sanitary boreholes that can not cause any type of health issues in the future.